All right, in this explainer, we're going to pull back the curtain on artificial intelligence and really uncover its most critical and honestly often invisible ingredient, the data it's built on.
Okay, so let's just dive right in. To really get what AI is all about, you have to ask a pretty simple question. What does it actually consume to learn, to grow, and to get smarter? The answer seems kind of obvious, but its importance, well, it just can't be overstated.
You know, every single AI model out there, from the one that suggests your next song to the one helping to fly a plane, it has this just insatiable appetite for one thing, and one thing only: data. It is the absolute bedrock of modern artificial intelligence.
Think of it like this. AI systems learn by example, pretty much just like we do. But, instead of a handful of lessons, they need millions, sometimes billions of examples to even begin to understand the world. And that whole process of gathering all that info, that's what we call data collection.
So where is all this stuff coming from? Well, literally everywhere. Every single time you fill out a survey, use an app, click on a website, buy something online, or even just like a post on social media, yep, you're contributing to these gigantic pools of data. I mean, self-driving cars alone are gathering thousands of images every single second. It's just a constant flow.
Now you might be thinking, okay, so more data is always better, right? But it's really not that simple. See, a mountain of data is totally useless, or worse, it can be downright dangerous if it's flawed, messy, or incomplete. When we're talking about AI, quality really does trump quantity every single time.
And this right here brings us to one of the single biggest challenges in all of AI development. It's what happens when the messy, chaotic, real world slams right into the super precise, logical world of a computer program. So what's so fascinating about this slide is how simple these differences look to us, right? I mean, we know that USA and United States mean the same thing, but to an AI, those are two completely different things. And these tiny, tiny little inconsistencies can spiral into major errors in the AI's logic and its final conclusions.
You know, there's a classic saying in computer science that just perfectly nails this idea: garbage in, garbage out. All it means is that if you feed an AI model a diet of low-quality, error-filled data, you can only expect to get low-quality, error-filled results. It is the golden rule of AI.
But, beyond simple typos and weird formatting, there is a much, much more serious problem lurking in our datasets, and that's the problem of data bias. So, bias happens when the data used to train an AI just doesn't accurately represent the real world. For example, an early commercial facial recognition system, got this, it had an error rate of nearly 35% for women of color, but less than 1% for white men. The AI isn't being malicious, it's just a mirror, perfectly reflecting the huge gaps in the data it was fed.
Okay, so we've established that real-world data is, well, often a complete mess. So how on earth do we fix it? Well, this is where the unsung heroes of the AI world come in to perform this massive task we call the Great Data Cleanup. If you picture a data scientist in your head, you're probably imagining them hunched over a keyboard, designing these super complex, futuristic algorithms, right? But the reality of their day-to-day job, it's actually pretty different.
In fact, the huge majority of their work happens way, way before any of that sci-fi algorithm building can even start.
That's right, research consistently shows that data scientists can spend up to 80% of their time just cleaning, organizing, and preparing data. Not building the cool AI, but just getting the food for the AI ready. It's a truly staggering amount of prep work.
So this whole meticulous process, it involves finding all the problems, the duplicates, the errors, the missing info, then fixing them by correcting all those inconsistencies, and finally structuring the whole thing so a machine can actually make sense of it. This is what turns that raw, messy stuff into high-quality fuel for an AI.
So, if this is such a critical and incredibly time-consuming job, how is it being made more efficient? I mean, spending 80% of your time just on cleaning, that's not exactly a sustainable way to innovate, right?
Luckily, engineers have some seriously powerful tools to help them out. Programming languages like Python have these special toolkits or libraries called pandas and NumPy, which are designed specifically to help automate this process, to filter data, zap errors, and transform formats way more quickly. And this really illustrates the end goal perfectly. When that foundational data is clean and well-structured, the AI models can train faster, they make way fewer mistakes, and the outcomes they produce are just far more accurate and reliable. Ultimately, this all points to a much bigger idea. Building reliable AI isn't just some technical puzzle. It's about being responsible, being ethical about the quality of the ingredients you're using from the very beginning to the very end.
So what's the really crucial takeaway from all this? Well, the quality, the accuracy, and the reliability of our most advanced AI systems will always be a direct reflection of the care we put into their data, which leaves all of us with a final, really important question to think about. As AI becomes more and more woven into our lives, who's responsible for making sure its diet is a healthy one?